Safer Chemicals Podcast. Sound science on harmful chemicals.
Hi, and welcome to the Safer Chemicals Podcast. I am Päivi Jokiniemi, your host. In this episode, I speak with two experts from the European Chemicals Agency about a recent study run by the EU Observatory for Nanomaterials. The study looked at product life cycles, waste recycling, and the circular economy for nanomaterials. Its findings show that we don't currently have a full picture of how nanomaterials in products, and consequently in waste streams, may impact our health or the environment. These knowledge gaps make it difficult to know how to recycle, treat, or dispose nanomaterials efficiently once products containing them are no longer used and become waste. Abdel Sumrein, the product manager for the EU Observatory for Nanomaterials, and Gary Watkins, working as a regulatory officer in the Support and Enforcement Unit, will be discussing ECHA's view on the study results and what more can be done to improve information on nanomaterials in waste streams. So grab yourself a cup of coffee and let's get started. Gary and Abdel, thanks for joining the Safer Chemicals podcast. Let's get straight to the point. What do we know about nanomaterials on the EU market and in our waste streams?
Hello, Päivi, first of all, and hello to everyone who's listening in here. I think the first thing we should get started with is the information coming to us from the REACH regulation. So we know that the REACH regulation was changed, and since January 1st of 2020, so about 2 years now, companies have had to submit information about nanomaterials in their registration dossiers. And what we've seen in the past couple of years is that companies have submitted registrations for around 130 substances. And this is covering around 440 different registrations to date. And each one of those registrations can cover potentially one or more different nanoforms. So already you see there's a number of registrations that have come in, and each registration has to have data in there about the hazard properties of the substance, the toxicology, the ecotoxicology. And what we're expecting is that more and more registrations will continue to come in the future. And then with the regulatory activities that ECHA has, more and more data will also come in from companies as they have to comply with the regulation. So already we see that a lot of registrations have come in and more will come in, and those will bring data with them. Now, the one thing here is that when companies register their nanoforms, they're registering it together with what is called the bulk substance, so the non-nanoform of the same substance. And they have to submit information on both, so on the hazard of the nanoform and the non-nanoform. But the one thing to keep note is that the tonnage there, so when companies are reporting on their volume of their nanoforms, they're actually reporting on the volume of the entire substance. So the data there is combined, and we don't know what is the volume of the nanoform versus the volume of the bulk form. But this is how the regulation was designed. As a starting point, the picture is positive in the sense that we have a regulation that requires information, and information now will continue to come in. Now, on the other hand, if we're talking about information about products themselves, so consumer products, the information about consumer products and nanomaterials in them is a bit more limited. So there are some databases out there, like the Nanodata, the CEN, the CPI databases, that do give some information about these, but they're not giving quantitative information. So you might know a particular product has a nanoform, but you don't know exactly the volume of it on the market. One thing that it is important to point out is that this is similar for to the situation for chemicals in general. So the REACH regulation brings in data about the hazards of chemicals, but you don't necessarily know which individual products contain which chemicals and in what quantities.
Yeah, thanks, Abdul. Yeah, this lack of quantitative data about nanomaterials on the market and therefore in consumer products, which of course eventually become waste. This complicates the identification of the predominant waste streams containing these these nanomaterials. But of course, here this is not it's not unique, since obtaining accurate statistics on all waste streams in general, it's always been an issue for society. So in that respect, the nanomaterial dimension is no different here. Research suggests that nanomaterials could be present in all major sources of waste generated in the EU. So here we're talking about things like construction demolition waste, manufacturing waste, of course, municipal solid wastes, the sort of waste that we produce at home or from commerce, in wastewaters, and also the treatment residues and byproducts that arise from those sort of treatment processes. However, the research that's available to us only provides a qualitative view or qualitative data about the presence of these materials, and so it doesn't give an accurate quantitative evaluation on their presence and concentration.
Thanks both. But why is it then important to know if a product that reaches the end of its life cycle contains nanomaterials? And what difference does the quantity make when it comes to treating them in the waste stage?
Right now, the hazards of nanoforms of substances are not necessarily going to be different or higher compared to the non-nanoforms. So it is not necessarily going to be required that we distinguish whether the waste itself contains a nanoform of the substance or not for the purpose of treating the waste in a safe manner. But if we are in the situation where we have the nanoform or the nanomaterial of that substance having a specific hazard that's different from the non-nanoform of the substance, then it might be important and useful to know the volume of the nanoform and the waste streams that relate to it, for the reason of determining what's the best waste management option for that stream. But that really depends on what information there is on the hazard of the substance. So like I said, if there's no differences in the hazard, then you might not necessarily need to know whether the volumes pertain to the nanoform or to the non-nanoform.
Yep, thanks, Abdel. Sure, I mean, the types of waste streams in which nanomaterials are found will determine the waste management or treatment options available for that stream. And some of these streams require mechanical or manual activities to be applied, such as handling, grinding, cleaning, finishing, transferring, those sort of activities, which are likely to lead to exposure to airborne nanomaterials.
But again, the exposure itself to nanomaterials doesn't mean that there's going to be a different hazard compared to the exposure to the non-nanomaterial of that same substance.
Then the study also talks about waste treatment for those products that we know contain nanomaterials. Are there efficient means there to extract these nanomaterials from the products?
Yeah, it's important to get one thing straight here, and that's that when we're talking about recycling within the circular economy idea, this is in the context of recycling waste types and components of bulk waste streams, and we're not talking here about recycling specific nanomaterials themselves from the waste. So we're not talking about nanos that may be contained within a bulk stream. So that's an important clarification to make here. But in terms of the treatment efficiencies, several of the case studies that were covered in the study on real incineration plants, for example, and experiments that simulated incineration showed very high efficiency, close to 100%, reported in some studies. High efficiency of things such as bag filters in preventing nanomaterial emission to air, Similarly, it found a high efficiency of removal of nanoparticles in wastewater treatment systems. However, in the case of landfilling, the efficiency of landfilling systems has not been systematically addressed.
If we then speak in very concrete terms about consumers, for example, so should consumers be worried about nanomaterials in products they buy, and how should these products be disposed of?
I always like to start out whenever I'm talking about nanomaterials with reminding people that the term nano or nanomaterial is not synonymous with dangerous or hazardous. What it really means is that you have very small particles and they meet a certain size definition. But the fact that it is small doesn't make it necessarily a cause of concern for the consumers. So as such, I don't think that consumers should be worried if a product contains nanomaterials any more than they would be concerned for a product containing, any other chemical. Now, we do know that the REACH regulation has been amended to make sure that companies have an obligation to provide information on their nanoforms that they are manufacturing, so that we as a society, regulators, industry can make sure that these chemicals are used, let's say, in a safe manner. So, if we're talking about how consumers should approach such products, I think they should approach them in the same manner that they would approach any other product. They should, of course, try to follow any relevant instructions on the label of the product. They should dispose of things safely, try to recycle their products as with any other product that they have. But there isn't a requirement or a need to handle products that have nanomaterials differently than they would handle a regular product, let's say.
And turning to the waste disposal dimension now. Sure, despite the deficiencies in the quantification of nanomaterials in waste, the current public information sources, they do still provide valuable information to waste managers so that they can determine the composition of waste and its classification so that they can fulfill their obligations under EU waste legislation. And these sources of information are also widely used by scientists to make estimations of mass flows of these materials to waste management facilities and their fate in the environment. And some of these mass flow models can support regulatory decision making in safety assessment.
Very interesting. Thank you very much. Then over to something a bit different. You, Gary, already briefly mentioned circular economy. If we talk about recycling and reuse, those are the terms that we very closely link to the aims of circular economy. What role do nanomaterials play in circular economy?
The study identified several areas of research where it was envisioned that nanos could contribute to circular economy. And these covered things like green synthesis of biomaterials, for example, from biowaste, and the use of nano additives in recycling of plastics or construction demolition waste. Also, the recovery of rare earth elements from waste and the use of nanos in wastewater treatment systems. Other applications that have been identified are nano remediation of contaminated land. However, the circularity of these solutions in the literature is questionable, I would say, and the research at the moment is purely theoretical. Most of the case studies that were looked at focused on investigating specific nanomaterials and looking at specific methods for nanomaterial applications. The application of these approaches has not been looked at in terms of the commercial viability or any evaluation of their safety has been undertaken.
So more research needed also
Yes.
there in the future. The study also highlights otherwise that there is a need to collect more scientifically valid information about nanomaterials and their safety during the life cycle of products. How should we go about this? What's your view? Who should be carrying out these studies, and how does this differ from the situation for chemicals in general?
That's a good question. It's important at this stage to highlight the fact that this publication is very much a baseline report describing the state of play and the knowledge gaps, if you like. In that respect, it can act as a stepping stone towards defining the scope of future investigations, which can be carried out by other players, commercial, institutional, or regulatory.
As for who should be carrying out these studies, I mean, some of those studies, maybe, will need to be generated from the regulatory processes that we have. So I talked earlier about the changes to the REACH regulation. Basically, that means that companies do have an obligation to submit information, at least about the toxicology, ecotoxicology of these substances that they're putting on the market. There, they will have to generate and do the studies that they need to fulfill their obligations. And then where ECHA or other authorities will notice that, some of those data are missing or inadequate, then we may send decisions saying that they need to generate more data. So that will at least address important information about the safety of these nanomaterials. Then it's also possible, even likely, that some of the answers to these questions, some of the data needed, will be also generated from research projects, people in academia are working, EU funding, all kinds of research projects, and that will probably address also some of the questions that are coming. But it's important to keep in mind that now that we have a change to the regulation, there really is an obligation for companies to submit the data to comply with that regulation.
Thank you, Gary and Abdel, for this interesting discussion, and also to you, our listeners, for tuning in. We will continue following this topic, see how the work develops, and keep you informed. If you are interested in the study, you can now find it on the EUON website at euon.echa.europa.eu. And you can find us on all your favorite podcast channels, so remember to subscribe at echa.europa.eu/podcasts.
Safer Chemicals Podcast. Sound science on harmful chemicals.